Hello student and welcome back to Stokes Theorem in Calculus 3. In this video we would like to verify Stokes Theorem for this vector field over the surface S. So if we have to verify Stokes Theorem, first of all, if we write Stokes Theorem as it's given to us, so this is f dot dr by Stokes. This is the same as the double integral, so we transfer a single integral over the boundary over any surface S that has the boundary C with curl of f dot ds. Of course, in this example, we have the surface S, so we know exactly what we need to do. And in this example, we need to calculate the double integral separately, and then we need to calculate the single integral separately and check if the two answers are the same. Now, if you have watched part 1, in part 1, we calculated a line integral for a different question. In part 2 of the videos, we calculate the double integral. So in part 3, we'll do both. So I would like to advise you to do two things first. If you didn't watch part 1 and part 2, please go and watch them, because everything here in this video is just similar to part 1 and part 2, but it's combined. Second, after you watch them, pause this video and try to solve this question by yourself. Find the first one, second one, and then play the video and make sure that the answers are identical. So I would suggest, because we just finished from part 2 and I assume you just finished watching part 2, I would suggest that we start with the double integral. So number 1, we will find this integral ds. Now, in order to find this integral, if you remember, this would be the double integral over a region of the curl of f dot, we need to find the parameterization for this particular surface using u and v. So first step, we will find the curl. Second step, we find parameterization and we find the derivative and the cross product. And then we will transfer this integral into a double integral and we will solve it. So let's do the curl of f, which would be the cross product between the gradient and f. If we do it as matrices, it would be something like this. Finally here would be minus 2yz, this is the first component of f, and then y, and then 3x. If we just look at it again, just to ensure, yes, 3x, y, and okay. Now, if we find this one, of course, first we have to cancel the row and the column of I, if we do it in the usual way. This is something in I, minus something in j, plus something in k. Now for the I, if we cancel the row and the column of I, what is left is derivative of y for 3x is 0, derivative of z for the y is 0, so the first part is 0. For the second part, derivative of 3x with respect to x is a 3, derivative of negative 2yz with respect to z is negative 2y. So what we will get is 3 plus 2y. Finally, for the k, if we cancel the column and the row of k, this will be 0, and this will be just negative 2y, and because there is, so this is just 2z. And that's the curl. So first we find the curl. Now the next step is we will go ahead and we will try to find parameterization for our curve. The best way is we have a small sketch here. The surface S is elliptical paraboloid. It will start at 5 and will go down to 1, something like this. So if we do the curve here, it will be like this one. That's my surface, which is z equal 5 minus x squared minus y squared, and it is part of z is in the plane z equal to 1. Now, the best idea to have the parameterization is, since I have, let me just write it down here. This one, I have one equation, 3 variables. Then 2 of the variables can be any 3 variables we choose, and the best one we choose them are x and y. The reason why, because if x is u, y is v, then z will be easily found to be 5 minus u squared minus v squared. This is the parameterization, and from this parameterization I can find r, which is u, v, 5 minus u squared minus v squared. So what is ru and what is rv? Ru will be 1, 0, minus 2u. Rv will be 0, 1, negative 2v. And next we need to find the cross product. So if we find the cross product, will be 2u, comma, 2v, comma, 1. And of course, the last step, we need to find the curl times this one. So the double integral s curl of f dot ru cross rv dA. This would be just double integral. Now for the curl of f, it is negative 3 plus 2y, and we multiply it by the second because it's 2v. Remember the curl starting with 0 and something else, so we just start from here, plus 2z with the third one, which is 1. And of course, this one would be double integral d. Now, if we return everything back to u and v, this would be negative 3 plus 2u times 2v plus, now 2z will be just 2v dA, which is, if we just simplify it here, would be, this will be negative 6v plus 2v. This would be just negative 4v. And this one will be just 4uv. Which is something we can handle here. Oh, I'm sorry, I think I did a mistake here. The 2z, the z is 5 minus u squared minus v squared. So there's a mistake here. I can just cancel this one here and go back here. So this would be what? It would be 10 minus 2u squared minus 2v squared dA. So this would be just double integral of negative 3v, negative 4uv plus 10 minus 2u squared minus 2v squared. Or just let me, just for simplifying things, I will take negative 2 as common here. So it will get u squared plus v squared. Now we need to find this integral, so we need to find the region between u and v. Copy. Paste it here. And now if we just see what is the region. Now if we look at u and v, we will find out that it will be like this. And this is the... Now, what is this exactly? This will be, of course, if we go back to z equal to 1, that's where we'll have the biggest circle. That means 1 equal 5 minus x squared minus y squared. So this means x squared plus y squared equal to 4, or similarly, u squared plus v squared equal to 4. So this is a circle of radius 2. And for the double integral, this will just turn out to be using the polar coordinate into 0 to 2 pi. So this integral will be 0 to 2 pi, 0 to 2. And now I have to change everything into the polar coordinate. So the first one will be minus 3r sine theta minus 4. So it would be 4r squared sine theta cosine theta plus 10 minus 2r squared. And then don't forget there is an extra r here because I'm changing to polar coordinate, dr d theta. And this integral will be 0 to 2 pi, integral 0 to 2. Now if we distribute the minus, it will be r squared sine theta minus 4r cubed sine theta cosine theta plus 10r minus 2r cubed d theta. If we do the first integral with respect to r, this will be negative r cubed sine theta, negative r power 4 sine theta cosine theta plus 5r squared minus 2 over 4 r4 from 0 to 2. If we just substitute 0, everything will be go away. So just we need to substitute 2. So we'll get minus 8 sine theta, negative 16 sine theta cosine theta plus 20 minus 8. D theta. Which is, if we just continue with all the calculations, the one that we will get is the following. If we do all the calculation, the answer should be, if we continue and everything is correct, we can just do the integral here. This will be 8 cosine theta minus, this can be function with derivative, so it will be sine squared theta over 2 plus this will be 12 theta from 0 to 2 pi. And if we do the calculation, now substitute, this will be just 12 times 224 pi up here. I'm sure, I think I did some mistake somewhere here. I think the mistake is it would be 10 minus 2u squared minus 2v squared. Plus 10. Okay, I think I know where's the mistake I did. It's from the beginning. the mistake is here. This one should be just v. So we have to change this one into v, this one into v. So this would be cancelled, this would be squared, this would be squared, this should be squared, this should be squared. And now the integral would be a little bit different here, because this has, we have to change it into, this one would be 8 minus 8 cosine 2 theta. So that's how it would look like. So it will change into 8 theta plus sine 2 theta, and here 4. Now if we do this one, what we are going to get, 12 minus 8, so it will be just 8 pi. And that's the answer for the first one. Now, let's check if our answer is correct by doing the opposite. Now, what we will do is we finish from this one. We know the answer is 8 pi or 8 pi. Now we need to find the integral straightforward and check if the answer is correct. Number 2, we will compute the single integral directly. So it means we need to have the curve itself. And remember, what is the curve? If we just talked about it here. Let's look like this. The curve is this one, this circle, which means z is 1 and x squared plus y squared equal to 4. So if we do the parameterization, we would use 2 cosine t, 2 sine t, z equal to 1, and of course t should be between 0 and 2 pi, and we assume it is counterclockwise. So if we just do the integral now, before we do the integral, let's find dr. So we have r of t equal 2 cosine t, 2 sine t, 1. So dr would be just negative 2 sine t, 2 cosine t, and 0. So the integral dr would be just the integral from 0 to 2 pi. And now we have to do the dot product between f and dr. So if you remember f, it starts with 2yz. We have to multiply first with first, so this would be 2 sine t. Second with second, it was, if we just go back to, it would be just y. 2 cosine t. Of course, third with third, we don't need to do it because it's already 0 here. 0 times anything would be just 0. Next step, put everything back in terms of t. So it will be 2 times, what is y? Y is 2 sine t. What is z? Z is just 1 times 2 sine t plus the y. What is the y? Will be 2 sine t times 2 cosine t, of course, dt. Now we work with this integral. It will be 0 to 2 pi. This integral will be minus 2 and 2. It will be 8 sine squared t plus 4 sine t cosine t dt. We almost can do this integral, so just let us use the double angle formula. This would be 4 1 minus cosine 2t plus 4 sine t cosine t dt. And now this integral, if we do it, it will be 4. It will be 4. What's the integral of 1? It's t. What's the integral of cosine? It is sine 2t 1 over 2 plus, Now this one, sine function and its derivative. So all what we need is to square it. So it will be 2 sine squared t, and we substituted 0 to 2 pi. If we do it just by calculator, the answer will be 8 pi, which is exactly what we needed. It is the same as predicted by Stokes theorem. The answer is 8 pi. By solving those three, part 1, part 2, part 3, I wish everything has been clarified now about Stokes theorem. Thank you very much for watching, and please try to solve as many questions on Stokes theorem as possible.